All right, so today's week 5, and we're doing the Visionary Cipher. Uh, it's named after a French guy who, basically this cipher was called the Unbreakable Cipher once. It was made I don't know exactly, like 1600s or 1700s, and nobody could figure out how to solve it until Francis Bacon or somebody figured it out, and they published it in like a paper, and apparently people were really mad because they were all encrypting their codes this way. But basically, this is French, so on the first E, there should be like a backwards accent, like it points northwest, but I didn't do that. All right, so this is just another look ahead. We have Baconian next week, so that's binary stuff. Pretty easy to understand. It's not, well, it's math, but it's simple math. It's like visual math rather than like bashy. Pollux and Morbit are Morse code. Rail fence, I don't even know what to call that. It's just like rearranging letters. It's kind of like an anagram. Patristocrats and Xenocrypts, you guys know about. There's just another copy and paste slide just to remind you guys that letter number conversions are really prevalent in Codebusters, so always make sure that you're working on those. Okay, so as you can see, the slide's not as full as it was for Affine because we don't have that much to go over for this one. So Affine had like letter number conversions, linear equations, modular arithmetic, modular inverses included in that. But for this, we're literally just doing letter number conversions. So that's something we've been working on. We should be pretty good. Modular arithmetic, kind of, but that doesn't include inverses. So if you remember how we had that table where like vertically they were matched up with the inverses, like 1 and 1, 3 and 9, and so on. We won't be using that for Vig because it's literally just addition and subtraction. And sometimes you have to get a little creative, but there's not like hardcore math involved or anything. Yeah, this is another refresher slide, so I'll just go over it again. But basically, mod math is I have this number, I want to take it mod a different number. That's my statement. And then what that statement means is that if I take the first number and I divide it by the second number, what's the remainder? So because in Codebuster, you only get to use like 4 function calculators or 5 function, and they don't have a lot of memory. So like if you have a TI-84 or something, you can just hit the up button and like recall like a quotient you had and then multiply, and it's really convenient. But on 4 function calculators, instead of dividing and find the remainder, since we're working in mod 26, you probably just want to do minus 26 or plus 26 like multiple times until you get to a number that's in between 0 and 25, so you can convert it to a letter. All right, so I'll teach encryption first because it'll make decryption a lot easier to understand. But basically, you were given A and B for Affine, and we saw that A and B relates to what kind of linear equation you're going to write out. But for this one, what you're given is the ciphertext because, oh, okay, that's wrong. You're given the plain text because you're encrypting. So remember, plain text is what we actually want to say. And you're also given this thing called a keyword. And using those two things, you're going to make the plain text into the ciphertext because that's what encryption or encoding is. So yeah, hello is our plain text. I just miswrote it as ciphertext. So if I just show this, I'm going to extend our message a little bit just so I can demonstrate a little better. I'll just say, hello, how are you? And I'm not doing any spaces here because for most math ciphers, spaces are negligible. Like they don't impact how you do your math. So it doesn't really matter if you put them in or not. So it says, hello, how are you without spaces. Not doing hello right now. And then it says we have this keyword loca. Keyword doesn't actually have to be a word. Technically that's a word in Spanish, but like I just put something random in there. The first thing you want to do when you're encrypting, let me make sure I'm not just doing the next slide already. Okay, yeah, it's already here. So I guess I'll do it on the previous slide and then we can look at it. But basically the first thing we want to do is we write out our plaintext as it's given. So hello, how are you? And then what the keyword is, it's basically like something you add the plaintext to. It's kind of hard to explain, but basically like our keyword is loca. You want to write your keyword directly below or directly above your plaintext, and like see how like one letter matches to one letter and they're like directly above each other. Yeah, so like now it looks like we ran out of our keyword, right? But like we did with Affine when we got a number bigger than 25, we just continue the cycle. So once we reach the end of our keyword, we just repeat the keyword again. So we do that as many times as necessary until we reach the end. So here, you don't need to end the keyword. Like I don't need the ka of loca because this is the end of the quote. I can just end with LO. And then I'm just going to write this again because it's a little messy. But basically, after you do your basic setup, which is just writing them on top of each other, what you want to do is convert stuff to numbers. So I'll just write that again. Yeah, so from here, you want to convert to numbers. I mean, usually you just do mental math. Like I can know that H is 7, L is 11, so they would add up to be 18. But we're probably not there yet, so I'll show it. So like if this is row 1 and that's row 2, I'll just show the equivalent numbers. That's a 7 down here. And that's basically hello, how are you as numbers for our purposes. And then you want to do the same thing with a keyword. And keyword's going to be easier because it repeats after however many letters it is. So you don't even have to convert after a certain period. Like that's loca one time, and then I don't even have to look. Like I just repeat that same sequence over and over. Okay, so here, oh, did not mean to draw through that. But here we want to add these because when we're encrypting with Visionary, we add. So if I just add vertically, 7 plus 11 is 18. 4 plus 14 is 18. And then so on. I'll put commas in between those just so we know where they're separated. 33. Oh, hold on. I formatted this weirdly, so didn't add them right. I'm going to draw columns to separate them. Yeah, that should be right. Okay, I just wrote them really weird diagonally. So we have 21, 34, 33, 14, 19, 4, 30. Oh my gosh. All right, never mind. Sorry, guys. I'm just going to rewrite the keyword because, like, obviously I did not write it straight enough for me to read it. Yeah, that's a good tip for you to do. If you're not doing the mental math, make sure you write them like as close beneath as possible because otherwise it can get really confusing. And if you don't discover that like you made a mistake or something until the very end, it's just kind of annoying to go back and redo it. All right, so if I try adding again, 18, 18, 13, 11, 25, 21, 16, 22, 11, 31, 6, 24, 25, 34. And here we see a lot of numbers that we can convert back to letters. Like 18 is S, and we know we can convert it to a letter. Like even if you don't know what letter it goes to, you can see that it's in between 0 and 25, so it has to go to some letter, right? But there's also things like 31 where it's not necessarily a letter yet because it's above 25. So the only place where you would need to apply modular arithmetic is where you see something that's not 0 to 25 inclusive. So all of this stuff before 31 is fine. If we just do 31 minus 26, we get 5 instead of 31. And then if we do 34 minus 26, we get 8 instead of 34. So I'm running out of space at the bottom, but basically your encryption is done and all you have to do is convert back to letters. So 18 is S, so S, S, and then I'll just carry on. L, F, G, Y, Z, I. So this is hello, how are you? And I just put them in brackets so you could see like what goes to what. But once you write the letters down, you don't need to separate them or anything. That would just be your encryption product. And like I was saying like a couple lessons ago, if it's not a monosub cipher, like if it's not an aristocrat, patristocrat, or xenocrypt, there is a possibility that something can map to itself. Like we saw that this is hello. Nothing goes to itself, but this is how, and W goes to W, right? And if you were solving an aristocrat, that would like set off alarm bell if something's wrong. But in this case, it's fine. All right, I'm pretty sure the next slide is just a representation of what I did. But I'll just go over the steps that I put here so it's a little bit more in your heads. So yeah, the first thing you would want to do, you set up the plain text going horizontally, and then you set up the keyword either like above it or below it. And you want to make sure like everything's spaced out very neatly so that you can add the right numbers together and not mess up like I did like 5 minutes ago. So yeah, that's the first thing you want to do. If you want to do that in like a table format, then that's cool. And also just to repeat, the keyword, once you write it once, that's not the end. You have to repeat the keyword as many times as necessary, like we did with a local, low. Yeah, you just repeat it as many times as necessary to get yourself to the end of the plain text. So then after that, you convert to numbers, add, and then fix any numbers that are above 25. You won't get any negative numbers here because you're adding positive numbers together, so no way to go below 0 doing that. But during decryption, you might get negative numbers, so instead of subtracting 26, you would add 26 as many times as necessary. Okay, so we have a couple examples. All right, so a lot of the times, Visionary, they will not like they will not give you appealing spaces. Like they will usually just have a 5-letter block and then a 5-letter block and then a 5-letter block, or like X amount of letters. Like here it's an 8-letter block, an 8-letter block, and so on. They just put them in blocks for you to do the math. They don't necessarily divide them where the words should be divided. So here the quote is, "What makes the desert beautiful is that somewhere it hides a well." Yeah, so it's kind of hard to read, but that's the quote. And then our keyword is compiler. Yeah, we have a Google Classroom. If you haven't joined yet, I'll send the code a little later. So since they already write the plaintext for you on a test, what I like to do is like this space is for your encryption product. It's for your ciphertext, so you don't want to use that while you're just like showing your work for math. So what I do is I just write the keyword like directly below here. And the reason I can do this is because like Like I can do the letter number conversions and the addition in my head, right? But it takes some time to get to there, so I'll just show some work off to the side too. But this is what I like to do, just to make sure that I'm not making any errors. And there are a few tricks to Visionary that make it a little bit simpler than just like addition, addition, addition. Unless you're like really fast at mental math and you know, you really trust your brain to not mess up a lot. Because sometimes dumb errors just happen, you know? All right, so here, this is what I was talking about. We don't finish compiler, we just get to compile, but it's fine because that's how many words we have in the quote. Okay, so somebody tell me what I do after they're set up vertically. Anyone know? Yeah. So we'd convert first. I guess I'll just do that above here so I can show it. Okay. So if anybody wants to like start converting to numbers starting from the back, I'll start from the front. And if you just like call out some conversions for the plain text, so like 11 for this one. But if you want to call those out from the back, then I'll start from the front. Or you can just do it from anywhere. Doesn't really matter. W, yeah. Oh yeah, you can either just do it like I was doing, like left to right or right to left or something, or you can just like pick a letter and then find all of the letters in the quote and then fill that out. Yeah, so you can like look for all the A's first or like look for all the E's. Thanks. Yeah, thanks. All right, so that's the plain text as numbers. And then what else do we have to convert if we want to add something together? Yeah. So, I mean, this one, you technically, because compiler repeats itself like 5.5, 6.5 times, you only have to do the conversions for one set of compiler, and then you can repeat the numbers, right? So, yeah. So if I, 2, 4, yeah, I think all of those are right. Nice job. So it's kind of meticulous, but just to make sure that you don't make any mental math errors, you would probably want to write it out. 12, 15, 8, 11. Here, we can just do the first 3 groups of 8 since it's encryption. It'll get a little bit redundant, but we can just stop here. All right, so I guess I'll do the addition and then you tell me what letters to put in, just so we can practice conversions that way. So I'll just go across and do the addition. $24 is Y. Yeah. Where do we have 24s? We have a 24 here. Don't see another. 21 is V. 12 is M. All right, anybody want to try a bigger number? Yeah, because minus 26 is 7 and 7 goes to H. Yeah. Okay, we don't have an actual 7 though. I'll just fill in 19 as T because that's pretty common. And then if you know your vowels, then 20 is U. Or you can just count back from Z and go, you know, like A, B, C, D, blah, 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 Z, Y, X. So then 23 is X. Yeah, that is F. Nice. And if you go one more back from X, then you get W. So 22 is W. Yeah. $13 is N. Yeah, you're killing it. Oh, and by the same token, we said 8 is I. So then 34 minus 26 is 8. So this is also I. Yeah, nice. So we just have 11 and 15 left. L, yeah. I was confused for a second, but then I realized that was lowercase. Any takers? 15? Yeah. So since it's encryption, we go from something that makes sense to something that absolutely does not. So we have Yavamilan ut lapawava thuntifx, if you want to pronounce it like that. But like that's our encryption so far. So yeah, don't be afraid of the fact that it makes no sense. And I think we have another example, but I'll just skip it since I want to get to decryption, and then we can try cryptanalysis too. And so if you remember, like when we weren't given A and B for Affine, that was called cryptanalysis. But if they don't give you A and B, they have to tell you like this quote ends with these two letters, or this quote starts with these two letters. In Visionary, it's kind of similar. They don't give you the keyword. They give you the ciphertext, and then they say like, it begins with these 5 letters, or it ends with these 5 letters. So it's like they're giving you a hint, but they don't give you the keyword. So you have to figure out the keyword in order to do the rest. But for now, we'll do decryption. It's literally the same thing. It's just subtraction and not addition. So encryption's addition, decryption, subtraction. That's all you have to keep in mind. So yeah, I don't have like a continued explanation slide because I feel like, you know, we know what's going on here. So if I said it's the same thing, what's probably the first step I should do with decryption? Just one step. You don't have to like line it all up, you know? I'm just looking for the first thing I should do when I'm looking at this problem. Keep in mind that I said you literally do the exact same thing except you subtract instead of add. Everything else should be the same. Yeah, actually you could start with that. But first, what do we like to do with this? All right, I'll just do it. Whenever you have Visionary, if you're given the keyword, so you can't do this in Cryptanalysis, but when you're given the keyword, the first thing you want to do is write the keyword. I choose below because it doesn't matter for encryption because you're adding, but when you're decrypting, it really helps to have the number you're subtracting by be below the thing you're subtracting from, just for like visualization. So since this is decode, let's not cut it off. Let's actually decode the entire thing so we can tell what the quote was. Okay, while I'm doing this, if somebody wants to start like calling out conversions in the chat, that would be great. For the ciphertext or the keyword, doesn't matter since we have to do both anyways. Okay, I'll start with a equals 0 since we have that a lot because we have digital. So 0, and then we have a couple a's up top too. 3, 8, 6, 8. Yeah, nice. And this is what I meant about having it below because this is a ciphertext A, so I put the 0 up top, and then this is a keyword G, so I put the 6 below because we want to do 0 minus 6 and not the other way around. All right, 1 second. Oh, whoops, I put a T instead of an I there. (19,011). Okay, so we're done with that, and now we just have like ciphertext stuff. So I actually don't see any other A's to put in, but are there any E's? That's pretty easy for us, right? So E is 4, so yeah. I mean, really, this strategy would be something you use if like you only had those anchor points down, but what you want to get used to is eventually just going left to right and being able to read them off, because that's definitely like the fastest, least time consuming way. Okay, we ran out. So yeah, I'll just demonstrate what I was saying. Like you want to be able to do this, and the Quizlet really helps with that. But you can see like a lot of the times we're going to end up with negative numbers. Like we're doing 8 minus 19 here. We're doing 0 minus 6 here. So definitely in encryption, I mean in decryption, we're going to have a lot more cases where we need to use mod math. All right, so that's done. And now we're just subtracting. So I'll subtract and then you call out what letters to put in. 11, 4. That's an 8. So if you like already know you're going to end up with a negative number, like here, what you can do instead of adding 26 to it after, you can add 26 to the top number beforehand and then subtract. Because if you think about it, it's just subtraction and addition. If you switch the places, it doesn't change the end result. But I'll just show it like this. All right, so everything's made into numbers. 4, 1, yeah. Honestly, Visionary isn't the most fun cipher, right? Because it's mostly addition and subtraction. But I had to teach it. But next week will definitely be more fun. It's a lot more random, Baconian is. Okay, so here it's -8. So if we add 26 to that, it's 18. So that's S. Here, -6, same thing as 20 if you add 26, so U. And I'll just carry on. And if you see a pattern, like this says be less curious, and then if you have and more, you can just kind of assume that the next word is curious. Like obviously you can confirm with math, but sometimes you can just take these shortcuts to make it a little bit shorter, easier on yourself. And this one's probably about ideas, yeah. So a lot of the time you can make the math easier on yourself. So it says be less curious about people and more curious about ideas. All right. Yeah, honestly, I think we're going to head to cryptanalysis and then we're just going to do some cryptograms because that's definitely more fun. But had to give like a crash course on this just so we had it in our pockets for the future. But cryptanalysis is definitely more fun than just adding and subtracting. Yeah, so here, time to break big brain, not break brain. Yeah, so you do kind of need a big brain for this. So cryptanalysis, you're not given the parameters you need. So you have the ciphertext here. You do not have the, well, obviously you don't have the plain text because otherwise you wouldn't need to do this problem, but you don't have the keyword. What they give you instead is they give you 5 letters mappings. So first 5 characters, P people minus the E, but obviously we can assume that there's an E after the L because no other word really looks like that. Yeah, it probably starts with people. Yeah, good idea. So if we just write that in, we need to kind of like reverse engineer this process in our heads. So I'll just write this. So I'm converting the ciphertext to letters right now, or to numbers right now. Okay, I'll stop there for a second. We're still doing decryption, and every Visionary cipher has a keyword. Otherwise, it's just not Visionary. So there has to be some keyword where if we do this stuff minus the keyword, it gives us PEO, PL, and then E. So we basically need to do this row minus something to get this row. And if you say like x minus y equals z, if you rearrange the equation, x minus z is also equal to y. That's if you add y to both sides and do minus y or minus z to both sides. So that's saying if I do ciphertext minus keyword equals plaintext, it also means that ciphertext minus plaintext equals keyword. So that's what we have to do in order to find out our keyword. So we're going to do ciphertext minus plaintext. So if I convert the plaintext, 15, 4, 14, 15, 11, 4, we basically need to do subtraction. And this is, we're finding out the keyword instead of finding out the plaintext here. So this is -9, 14, 2, 10, -2, 17. And what we have here so far is -9 is the same thing as 17. So we have R, O, C, K, Y, R. So because we see that R appeared again, yeah, the keyword is Rocky, because I can't think of a word that's Rocky plus R or something, right? Because usually the keyword will be one word. It probably won't be like Rocky Road ice cream or something, because there's no way you could figure that out. So assuming that the keyword is Rocky, now it's just decryption, right? There are some times where it's like kind of confusing though, because on the last test I took, yeah, it was Soup. So Soup is UPenn's tournament. On that test, I don't usually do Visionary, but my partner was talking about it. They had this cryptanalysis thing, and it looked like the keyword was lie. It gave LIBRA, and that's how much you could get from the 5-letter hint at the beginning. Libra by itself is a word, right? I forget what those are called. It's like a star sign or something. Zodiac. But there's also like library, librarian, librarians, I guess, but I don't think they would do that. So there's a lot of things you need to take a look at in order to be able to determine like what the actual keyword is. So there's some trial and error involved. And also don't do what I was just doing and write the keyword above the ciphertext. It's going to like mess with your brain. So I won't erase everything else, but I'm going to start writing the keyword below the ciphertext because you want to make sure you're subtracting the correct things from each other. So this is a K minus O. So 10 minus 14, not 14 minus 10. That's why I was saying, please don't do what I just did. Yeah, I'm confusing myself already. I think I'm just going to convert the top first. And then look at it. $17, $14. $17, $14, 2, 10, 24. And then because this is our keyword, or at least we're assuming it is, it could be like rocky road or something. But I mean, usually test writers aren't cruel like that. But we have to assume that it is in order to like actually confirm our assumption and get somewhere. So we're writing this down. All right, and I'll just do these three subtractions first since we already have it written down, but this is -4, this is 8, and this is -7. -4 plus 26 is 22. So we have a W. And since it starts with people, my like mind is telling me it probably starts with people who. Actually, that's wrong, but it could be people with or people who. And judging from this, I is 8, and then -7 is 19, and that's a T. It looks like people with. So I can confirm that by doing a 5 minus 24, -19, which goes to 7, which is H. So it's really personal preference if you want to convert all of these first and then subtract, or if you want to go one by one and just make sure that the quote makes sense as you go along. That's also something you could do. Probably if you want to go one by one, that's probably a safer way to do it. But if you think you can be pretty fast with letter number conversions, pretty fast and pretty accurate, then you can go that way. Honestly, later down the line, you won't do either. You'll just kind of do the conversions in your head and then subtract in your head too. I'll just stop at this line though. I mean, I won't stop decrypting at this line, but I'll stop converting at this line and then convert after we get all these subtractions done. So this was -19. Okay, 6 is G. -12 plus 26 is O, because 14. 2 minus 2 is 0 is A. And then that's the rest. So people with goals. Goals is probably a word within itself. It's probably not leading into some other word. So if we continue subtraction, here we have -8 is equal to 18 because you add 26. I'm just going to stop saying add or subtract 26 now because I think you guys get it. So S is -6 is 20. -22 is 4. Yeah, so it kind of looks like it's going to say people with goals succeed. It could say success, but you don't think a noun could come after a noun in a sentence, right? So goals success wouldn't make too much sense. And here, oh, I just wrote E up there. That should be a 4, but 4 -24. So this would be C. Okay, it's succeed, and then this is an E. So it's probably saying succeed because if I look 17, yeah, it's definitely succeed because you can check with your subtraction, but honestly, you can just go ahead and write some stuff in sometimes. And then here we have -7, and that's 19. And since it's saying people with goals, this word that starts after because is probably they, but we don't know for sure. So we can check. So 7, 4, -2, 10, -13. This will be HEY. So it was they. And then we have KN. KN really only appears if it's no, like KNOW, the word no. And this is the reason I was saying you probably want to write the keyword below your ciphertext because it just makes it so much easier to subtract. All right, so we can finish this up. negative 12, negative 14, 22, 7, negative 22, negative 9, 4, 19, 7, negative 22, negative 2, negative 9, 4, 6, negative 12, 8, negative 13, 6. Okay, so negative 12 is 14. So O, negative 14 is 12. So M. What? Okay, negative 4, not negative 14. Negative 4 goes to 22, so it's W. Yeah. 22 is W. Negative 22 is 4. Negative 9 is 17. This seems wrong. 17 is R, yeah. Okay, yeah. 4 is E. I think I did something wrong. Oh, never mind. It's a contraction. Yeah, whenever contractions appear and you don't have apostrophes to help you, it looks really weird. Because I thought this says they know where they re going, but it's there, like they apostrophe re. So here it says people with goals succeed because they know where they're going. And our keyword was rocky. And I'm just going to repeat this again. Even with the 5-letter hint they give you, you may not know the keyword right away. Like I was talking about before, if it's Libra, if that's the keyword that you find from the 5-letter hint, it could be Libra, it could be library, librarian, librarians, libraries. You just have to start from the most obvious ones, like the shortest ones, like Libra, and then branch out. And somebody asked, like, can the keyword be longer or as long as the quote itself? Not for Visionary. There's a variant of Visionary called a running key, where the key is like super long and it never repeats because the quote is just too short to make it repeat. It used to be a part of Div C, but it got removed last year. So like, for example, if you know like how they give the reference sheet at the beginning of the test, like if you've seen the Topes things, they would give like the Pledge of Allegiance and like the Emancipation Proclamation, like they would literally give you the different speeches, and then you might need to use running key during the test. So that's like really annoying, obviously, but they got rid of it. But basically, I went off on that tangent to just say that the key in Visionary needs to repeat. It's going to be pretty short. All right. For the rest of the time, after I like go over some stuff, we can just do some cryptograms. But basically, homework, keep doing cryptograms because that's definitely the single most helpful thing you can do, and it's just pretty fun. There's a couple different games on Puzzle Barons. There's like not crosswords or something, but there's something called drop quotes. There's different like Codebusters related things that can really help you. So if you go to like the top right, it says more games. If you click on that, you can like check them out. I'll have a Visionary JSON. This one is probably only going to be like 6 questions because Visionary is just kind of tiring to do. So I won't have like a 20-question thing lined up. It'll be 1 aristocrat probably and 6 Visionary. Letter number conversions as always. And then next week we have Baconian. Yeah, I can't really get into an explanation of it right now because it's kind of far in depth, but we can just go ahead and do some cryptograms for fun. I think I've done this before here, but yeah, just call out what letter you think goes where, and then, you know, we can act as a team. I would actually look at the second word. It's a common word pattern. I'll just click around in it if you need a little bit of help to see what the word is. It's really the first 2 letters and these 2 letters that kind of set off alarm bells when you're looking at it. Also, the fact that T is really common, so you might just make a guess about what T could be. Yeah, maybe that'll help clear up what this word is. Oh wait, actually, you could technically look at what I is too, because there's only a couple different letters that are super common and can both start and end a two-letter word. What I mean by that is, you see, this is something, like I ends this two-letter word and it also begins this two-letter word, and the only letters that can do that are like O and T, S, N, but S and N rarely happen, so it's usually T or O. Yeah. The reason I would not think it's O this time is because we have it coming before an E in this word, and English does not like O's and E's together in that order. So I would say it's T. And then if that's T, what does this have to be? Yeah. Oh, nice job. All right, this is a little bit more advanced, but if you see a T and an O here, there's like a very common way words can end that use a T fourth to last and an O second to last. It's kind of hard to explain in words. Yeah, shun, basically. If you see a T fourth to last in a word, it's probably shun or ting. Ting is less common though. People, yeah, that's what I was going for. That's a common word pattern. Believe is actually a really good guess because it actually appears a lot, but it's not believe here because if it were believe, the I and the E would be together. And I think the number of letters isn't exactly matching. Uh, can you see what ROI goes to? Oh, yeah, temptation, that works. And the reason you can't fully trust letter frequencies is that this word is definitely temptation, but A only appears once. So kind of messes with your brain, but letter frequency isn't the end all be all. That's my point. Most, yeah. Same thing with S. It should be pretty common, but it's only once here. Actually, this word should be kind of familiar because I don't think another four-letter word really ends like that in English. Unless you're talking about like atom, but you don't see that in quotes a lot. Yeah, from. Keep in touch. Yeah, that's kind of, yeah, that's a pretty good guess. Yeah, would or could, but if you just think about like the flow of the sentence, most people could like to, like would like to just fits more, you know? Yeah, be delivered. Could versus would is kind of like a common issue in solving a lot of cryptograms, but what I like to do is just I hit would first, I press enter. If it tells me my answer is wrong, then I just hit C to make it could, and then I check again. Yeah, it's all right. Oh, actually, I think we set the slowest record on this one, so nice. Yeah, a record is a record. You're not wrong. All right, this one looks a bit harder. Okay, I think I can see what it is. How do I explain this? So basically, you can see that Y ends multiple two-letter words. So we have PY and we also have XY. And yeah, there are multiple letters that can do that. Like you can have is and as, you can have in on, and on. But the fact that Y is pretty common and also P and X are super common, like this is kind of a stretch, but I think Y is O. Like it and at also works, right? And I guess I was kind of making this a trick question by saying it's super common. But the reason that I think it's O is because, yeah, X could be T, P could be T. In this case, I think P is T, CX. Wait. Yeah, honestly, I can't really explain why I think P is T, but I'm pretty sure it's T, so I'll just put it down. But honestly, it's fine. Like what I would do, you basically just like plug it in, and if it looks weird, you take it right back out, and then you put it somewhere else. What were we talking about before for this kind of ending? Yeah, it's probably shun. To tell, yeah, that should actually clear up a lot of the rest of the thing. Position, yeah. Own, yeah, nice. Their own, yeah. So now it's starting to make sense, right? Their own story. Yeah. So by, very, and then we pretty much almost have it done. We just need to plug in a few letters. Should. Objects, yeah, yeah. Objects is correct. This one might be a little bit hard to see, but you should see that this has to be a vowel. Yeah, arranged. I don't think we set the slowest record on this one. That was pretty good. Yeah, we're half of the slowest record since 390 is the slowest. So nice. All right, we can do one more and then finish up. All right, this one should go by pretty quick. The first word is a very common word pattern. If you see that, can I do one? Sure, I'll flex on you guys after we do this one. All right, but third and the fifth letter are the same, and they're super common. And the first letter is super common. That should tell you something. There, yeah. It could be there or these, but because we have this second word, which if you want to take a guess at, yeah, there are, it's probably not these, and it's probably there. Oh, no, it's good. So usually if you have a there are sentence, it's there are no, or I guess it could be in weird circumstances, but it's usually there are no. So I'm just going to put that. Yeah, P is I. I don't know if you can get this word, but yeah, time. That makes it easier to get that word. Limits. Yeah, you have a lot of good guesses. Yeah. Have, himself, distance. Yeah, so now you can just see that the rest of it pretty much fills itself in. So a lot of cryptograms is about like finding the first word pattern. Yeah, touch. The reason it's not find is because it matches up over here, so it's actually wind, because we need to finish no, yeah. Yeah, it's not mind either, for the same reasoning. Yeah. Things. Yeah. But may, yeah. Any guesses for this word? Oh, I guess this is a hard one. Okay, I'll just read it. I'll read the rest of the quote out loud and see if you can like anticipate what the next word should be. There are no limits to either time or distance, as man himself may make them. So it's talking about how there are no limits, and then there's this, yeah, except. I was gonna say there's this exception, but that kind of uses that in the word. Okay, yeah, I'll do one, and then we can finish up. Oh shoot, that was right actually. Okay, yeah, I don't know. I don't know what you guys really get out of that, but sure. So, all right. Yeah, I made a record. Too bad I wasn't logged in though. So now it'll just say that a guest has a record. Yeah, so next week we'll do Baconian. I'll post the homework JSON soon. See you guys.